Let's look at this problem. Show that the volume of the cone is this one. So to show that the volume of a cone is this one, you must know the equation of the cone. So because we are not given more information about this, we are given the height, the radius, and the hypotenuse of the cone. So because we are given the hypotenuse, we can able to find the value of r using the Pythagoras theorem. So because we have that one, you'll just cut the sides that we have to deal with. So cutting the side, we'll cut this side like this. The radius is the same. So you'll draw nicely. Because we are given h and given r and 4. So here we can use the Pythagoras theorem because the angle here is 90 degrees and the other side is given. So we can say, what does the Pythagoras say? So it the square of one side is equals to the square of the other two sides, the sum of the square of the other two sides, which is Pythagoras theorem. So using the Pythagoras theorem, which is h represents the hypotenuse, so it's 4. So this side is hypotenuse. So O is the opposite side, this is h. So we put h here, square, minus r, which is the adjacent side, this is the r. So making r squared the subject of the formula, we'll take the h to the other side, and then we'll have something like this. Squaring both sides, putting a square root, not squaring, putting a square root both sides. You know that 4 square it's 16, right? You write 16. So now we have r. So what is the equation of a cone? This is the equation of a cone. So we can substitute some of the problem. So we use this equation. So we have something like this. So we have r square, you substitute the r square. So you substitute r. So square this one, you have 16 minus h. And then multiplying by h inside, you'll have something like 1 over. Multiplying by 1 over 3 to this side and this side, and multiplying by h, you'll have something. They multiply by this. You'll multiply by this, you'll have 3 over pi h squared, and multiplying by h should be h cubed. So this is the volume. This is how you get the equation of the volume of a cone. So let's see next question. What does it say? Determine the value of h for which the cone will have a maximum volume. So maximum, minimum, you have to derive. You have to derive according if you're asking about the maximum, minimum. So I have an equation like this. So we'll say dv over dh. So deriving this one, you'll have something like eliminating the h, you'll have h is off, and then this one will multiply here. The 3 will multiply in front, so here you'll subtract 1 from this one, you have 2. So the 3 will cancel the 3. But remember, when they talk about the maximum or a minimum, you have to equate dh over dv over h to 0 and solve for you equate to 0, and then take everything like this one to the other, not everything. Okay, let's take the h to the one side. So taking h to the other side is the same as this. So dividing by pi both sides, the pi will cancel the pi. So the h is this one. Then we are done. You can simplify it, put it in a calculator, simplify. If they ask you the value of this, you'll substitute the h here, the value of h. If they ask you the value of the volume. So there's no question that we have been asked here, but if in case they ask you to continue, they say find the volume of the cone, so we'll take the h and substitute it here as an